So you all had got the data. So today we start with regression analysis, and then we will go the part remaining on the first lecture, that is data entry, related to data entry. First we open the data set, that is car sales. Suppose you are going to purchase a car, then in that situation, what the features you would like to see in the car? आप लोगों को अगर कार खरीदनी हो तो आप लोग कार में कौन कौन से फीचर्स देखना पसंद करोगे? Safety, that is one thing. First one, I think it will be its price. If it will suit to your budget, then you will go for other features. Okay. Otherwise, you will not want to see that the features of that particular car. Number two, you would like to see the mileage of the car. How much kilometer it goes into the 1 liter of petrol. Then you would like to see the power of the engine, that is how much horsepower of the engine is. What is its wheel size, whether it is large or whether it is small. अगर व्हील बेस स्मॉल होगा तो आपकी गाड़ी के पलटने के चांसेस ज्यादा होंगे, अगर व्हील बेस बड़ा होगा तो गाड़ी के पलटने के चांसेस कम होंगे. गाड़ी की विड्थ, गाड़ी की लेंथ, आपके घर में गाड़ी पार्क हो सकती है कि नहीं, दैट डिपेंड्स अपॉन विड्थ एंड लेंथ. And there in the same things are available in the data set. It's how much one is manufactured, that is the company which is manufacturing the cars, their detail in first variable. Which model of the car is considered, that is in second variable. Third variable is how much units of the car has been sold. Fourth variable is resale, which tells what is the resale price of the car. मतलब अगर कार को आप दोबारा बेचना चाह रहे हैं तो उसका प्राइस क्या है. Fifth is type, whether it is automobile car or it is truck or it is any other vehicle, that is in type. Sixth one is price, which shows the what is the actual price of the car. Then engine S denotes what is the engine size of the car. Then horsepower. Then wheelbase, that is size of wheelbase. Then width of the car, length of the car, its curve weight, fuel capacity, that means how much petrol you can load into the car. Then its mileage, which is in mpg. Okay. Now, for studying the regression analysis, first we would like to see whether variables are related or not. There are 3 steps in regression analysis, but generally होता ये है कि हमको ये पता करना है कि हमको रिग्रेशन लगाना है. हमने प्रीवियस स्टडी से देखा और हमने अपना डेटा लिया, इंडिपेंडेंट वेरिएबल लिया, डिपेंडेंट वेरिएबल लिया और हमने उस पर रिग्रेशन लाइन फिट कर दी. बट इन सम सिचुएशंस ऐसा भी होता है कि हमारे वेरिएबल्स आपस में रिलेटेड ही नहीं है, तो हमको रिजल्ट नहीं सही मिलेगा. तो सबसे पहला काम है हम ये चेक करेंगे वेदर वेरिएबल्स आर रिलेटेड और नॉट. इफ दे आर रिलेटेड एंड लीनियर, then how much strong the relationship is. How much strong is answered with the help of correlation coefficient. If variables are highly correlated, then we will go for the regression analysis. Okay. So for checking whether variables are linearly related or not, we use scatter plot. Do you remember scatter plot, which was told by Shambhavi Mishra ma'am? Then draw the scatter plot between resale and price. On drawing the scatter plot, you will see such kind of a picture. That means, which indicates that if price is increasing, then its 4-year resale value is also increasing. Generally ये होना भी चाहिए. That is called as positive correlation. अगर आप गाड़ी 10 लाख की खरीदेंगे तो आप चाहेंगे कि 4 साल बाद वो कम से कम 5 लाख में बिके. अदरवाइज उसको परचेज करने का कोई मतलब नहीं है. वहीं अगर आप नैनो खरीदेंगे तो आप उसको 5 लाख में नहीं बेच सकते, वो आपकी 1 लाख या 50,000 में ही बिकेगी आफ्टर 4 ईयर. दैट मीन्स अगर उसका प्राइस कम है तो उसकी रीसेल वैल्यू भी कम होगी, अगर उसका प्राइस ज्यादा है तो उसकी रीसेल वैल्यू ज्यादा होगी. So that trend is also obtained in our scatter plot. So we can say that the overall impact of the scatter plot is that price in the 1000 and 4-year resale value are positively correlated. Now, and overall impact is also linear. Now, how much strong the relationship is? For this, we calculate correlation coefficient, which was, I think, already told by Dr. Anupma ma'am. So for correlation, we will go to analyze, correlate, bivariate. Here we take 4-year resale value, then price in 1000 into the variable box and click on OK. Now this table is obtained. If every column shows the correlation between row variable and the column variable. Okay, repeat the steps. Go to analyze, then correlate, bivariate. Click on bivariate. A window will be open like this. Put the variable 4-year resale value and price in 1000 into the variable box. Then click on OK. So you can see that the correlation is high between price in 1000 and 4-year resale value. Here in first box, it is value 1. It shows the correlation between 4-year resale value and 4-year resale value. Column variable is 4-year resale value, as well as row variable is also 4-year resale value. The correlation of the variable from itself is always 1. किसी भी वेरिएबल का अपने साथ में कोरिलेशन हमेशा 1 होता है. तो ये जो आपका चार्ट बन के आ रहा है, इसमें डायगोनल वैल्यूज 1 है. दैट मींस 4-year रीसेल वैल्यू की 4-year रीसेल वैल्यू के साथ कोरिलेशन 1 है, एंड प्राइस इन 1000 का प्राइस इन 1000 के साथ कोरिलेशन 1 है. But we are interested in the correlation between Fourier resale value and price in 1000. So its value is 0.954 and it is positive. So we can say that the price in 1000 and Fourier resale value are positively linearly related, or you can say they are highly positively linearly related as correlation is high. The correlation between 0 and 0.25 is taken as weak correlation. 0.25 to 0.75 you can take as moderate. 0.75 to 0.21 you can take as a strong correlation. And if it is 1, you can say it is perfect linearly related. And if there is 0, you can say that variables are not linearly related. You cannot say that variables are not related. You can only say variables are not linearly related if correlation comes out to be 0. In that situation, variables may be linearly, non-linearly related or maybe not related. So non-linearly, that means their overall impact may be a diagram of circle, that may be a diagram of parabola or some other diagram. In that situation, you will get correlation also 0. So in that situation, we judge with the help of scatter diagram. If scatter diagram shows some impact, that is a curve shape, then we said that variables are curvilinearly related, whether correlation is 0 or not. But if the scatter plot is parallel to some axis and correlation is 0, then we said that variables are not related. That is, there is no impact of one variable on the other. For scatter diagram, go to graph. Then in legacy dialog, there will be second last option, scatter oblique dot. Click on that. Then select simple scatter. Take any one of the Fourier resale value and price in 1000 on x-axis and other on y-axis. And click on OK. You will get the scatter plot. Now, as our variables are linearly related, we can fit regression model. Okay. For fitting the regression model, we will go to Analyze. Go to option Regression. There is second option, which is Linear. Click on that. Again, I am repeating. Analyze, Regression, then on Linear. जब आप लीनियर पे क्लिक करेंगे तो आपको एक ऐसा विंडो ओपन होके मिलेगा. नाउ इस विंडो में there are several boxes. One is dependent, other is independent. These two are most important for fitting the linear regression model. Whereas there are selection variables, label cases, and weights, which we are not going to define. Now, dependent, what value will be dependent on the other? What will you say? Whether Fourier resale value depend on the price or price is depending on the Fourier resale value? Okay. So I am getting the correct answer that Fourier resale value will depend on the price. So which variable is depending on the other is taken as the dependent variable. So we can put Fourier resale value as dependent variable and price in 1000 as independent variable. Is it clear? Then we go to statistics. Here, okay, options are checked, that is estimate and model fit. We will discuss other option, but that will in multiple linear regression. You can click on descriptive also, then click on continue. There is option of save. Using this, you can save some values, that is predicted value and residuals and some other value. Predicted values is when you fit the model. If you consider the equation as it was told, it will be y is equals to beta naught plus beta 1 plus epsilon. So epsilon is error term. When you fit the model and obtain the value, then in that situation error is removed. So that value is called as predicted value. When you obtain the estimates of beta naught and beta 1 and put into the model, like you get beta naught as 2 and beta 1 as 3.5. Then you can say the equation is y is equals to 2 plus 3.5x. Now, if you change the value of x, you will get the value of y. So that value of y you are getting from this equation is called as predicted values. So you can save that predicted values using this option. We use generally unstandardized. Statistics. Sorry, it is option save. And then we go to residual. If you want to check whether residual is too much high, that is error term is very much large, it is, you can say it is estimate of the error term. So you can use unstandardized residuals. Then click on continue. Then click on OK. Click on continue, then click on OK. Now you can see that first table is descriptive statistics. As online participants are asking to repeat, I am repeating it. Go to analyze, then on regression. Go to linear. In linear, put Fourier resale value as dependent and price in thousand as independent variable. Then click on statistics. Select the option descriptive also. Click on continue. Then click on save option. You can select unstandardized predicted values. As well as you can select unstandardized residual values. Then click on continue. Then click on OK. It is saved dialog box. There are several values in unstandardized, standardized, studentized. Their formulas are different. Unstandardized is nothing but the estimate predicted value of y minus beta naught minus beta 1 x. Simple. When you subtracted from mean and divided by standard deviation, you will get standardized. Okay, so original value are unstandardized. When you convert it into the normal shape, you would like to convert it into the normal, then you can use standardized. Then there are one studentized, which is given by a statistician, which is called as student. That is, all the other values are obtained with the help of unstandardized coefficients. Okay. For unstandardized, it is not necessary mu is equals to 0 and variance is equals to 1, but for standardized, mu will come out to be 0 and standard deviation will come out to be 1. Now click on continue, then click on OK. So first table is descriptive statistic, which shows the mean and standard deviation of the variables. So overall for the data, the average resale value is $18.05937,000 and its standard deviation is $11.549233,000. As the units of the variable was 1000, so here when you interpret, all the values will comes out to be in 1000 in descriptive statistic. Similarly, the price of the vehicle, average price of the vehicle is $26.09588,000. Now correlation I have already explained. Then there is another table, variables entered or removed. There is only one variable, so you will see only one variable in that table, and that is for independent variables. Okay, it will not show any dependent variable, it will show only independent variables. You are using one, it is showing one. If you use 5, it will show that 5 variables. Then next table is model summary. In model summary, there are R square, adjusted R square. So what is R? R is called as multiple correlation coefficient. It tells that if you are using more than one variable, then it tells the joint effect of all the variables over the dependent variable, not of individual variable. Here you are using 2 variables, so you can see that variable value of R and correlation between price in 1000 and resale value will be same. Here you can see the correlation is 0.954. And here you can see the value R is also 0.954. Now next value is R square. R square predicts how much variation in your dependent variable can be explained with the help of independent variables. So value of R square is 0.910. So you can say that 91% variation in your dependent variable can be explained with the help of independent variables. यानी कि resale 4 या resale value में जितना variation हो रहा है उसका 91% हम explain कर सकते हैं उसके price की मदद से. Remaining 9% may be caused by its horsepower, its engine size, its fuel capacity, or other variables which we are not considering, or you can say simply due to error term. Next is ANOVA. ANOVA tells whether the model you have used or model you have picked is good enough to explain the date variation or not. It is explaining 91%, it is good. But you have seen that testing of hypothesis, it was told that, I think, we generalize the results of the sample for the population. हम सैंपल जो लेते हैं उसके जो हमारे रिजल्ट्स आते हैं उनको हम पॉपुलेशन के लिए जनरलाइज करते हैं whether they are holding or not. तो इसी तरह से हमने मॉडल तो एक फिट कर लिया, लेकिन क्या ये मॉडल ओवरऑल अच्छा फिट है? कहीं ऐसा तो नहीं कि हमने बीटा कोफिशिएंट्स लिए और हमारा बीटा कोफिशिएंट 0 के इक्वल हो फॉर द पॉपुलेशन. So it tells the null hypothesis that model is not fitted good against the hypothesis whether model is fitted good. Or in terms of symbols, you can write H0 such that beta is equals to 0 against H1 such that beta not equals to 0. Generally, we contain the equal to sign in null hypothesis. So for that purpose, we use F statistic and its p-value, which is mentioned in SPSS as SIG value, or you can say significance value. It is compared with the level of significance, which is generally taken as 5%, and value of p-value is very, very small. That is, it is showing 000. That is, it is not. It cannot come up to 3 digits. It may occur value up to 4 or 5 digits. So you can say it is highly significant. That means your model is also fitted good. Which one? This ANOVA table. ANOVA tells whether your model is fitted good or not. So for testing it, we make the null hypothesis that model is not fitted good, and alternative hypothesis as model is fitted good. Since p-value comes out to be smaller than 0.05, which is level of significance, so we can say that our model is fitted good. That is, null hypothesis is rejected. Okay. You would like to explanation of all the elements which are in the table. Okay. So for ANOVA table, we have certain columns. First column is the variable column, in which the source of variation is mentioned. There are 3 sources of variation. One is called as model or regression. Second is called as residual or error. And third is for the dependent variable, which is called as total. So total variation, variation explained by regression, and variation caused by the residuals. Second column is sum of square. Sum of square tells the original value of the variation. For it, I have to use where it is. Okay. You fit the model y is equals to beta naught plus beta 1 x plus upside. Okay. When used, this is called as dependent variable or predictor. This is called as error. Okay. Its estimate is called as residual. Now, what is the degrees of freedom? Degrees of freedom is generally called as the number of independent terms in the expression. Whether you are writing the t expression for t-test, you are writing the expression for chi-square association. So there are number of independent terms are in the expression. Here in the model, we have only one variable, which is Fourier resale value, sorry, price in 1000. So for regression, its degree of freedom will be 1. For total degree of freedom, it will be number of observations in your data set minus 1. So in your data set, there will be 119 observations, and you subtract 1 from it, you will get 118. And difference between the degrees of freedom for total and regression is the degrees of freedom for residual. That is 118 minus 1, you will get 117. Then mean square is nothing but the sum of square divided by respective degree of freedom. So for regression, you divide 14319.890 by 1, you will get same value as mean sum of square, whereas for residual, it is 1419.54, which is divided by 117. So you will get mean is sum of square as 12.13. Then take the ratio of regression sum of square by with the residual. That is, in numerator, it will be regression sum of mean sum of square, and in denominator, it will be residual mean sum of square. So you will get the value of F statistic. And using this F, you can easily calculate the value of P. So this P value tells that your model is fitted good. Now there is another table which is called as coefficients. It tells that how much variation, there are two values. One is constant, other is for price in 1000. Constant is for beta naught in the model, that is you write model y equals to beta naught plus beta 1x. Then for beta naught, it is constant. That means whether price is, if you take price in 1000 as 0, there will always be some resale value, and that resale value will be minus 2.278 thousand. And for price in 1000, the value of beta is 0.779, which indicates that if you change 1 unit in the price, then resale value is changed by 0.779. That means if for price in 1000 is 0, then your 4-year resale value is minus 2.278. When price in 1000 will become 1, then you add 0.779 in minus 2.278. You will get the value of, again, predicted variable. Now model test. Okay, I think it is sufficient for univariate linear regression model. Now we will go to multivariate. Here I have told that we have considered only one variable as independent. Now we consider more than one variable as independent variable. Again, for it, we will go to okay, there is no such question that can be taken in. For fitting multivariate linear regression model, or you can say multiple linear regression model, we can go to regression, again go to linear. Now I have first taken as one independent variable. Now I will take more independent variables like engine size, horsepower, wheelbase, width, length, curve weight, fuel capacity, and fuel efficiency. Put all these variables into the independent variable box. Again repeating, go to linear regression, then go select the other variables you have not selected and put into the independent variable box. I am not changing any other option, whether it is statistics, whether it is save, whatever you take, by default, it will remain tick. Okay. That means if you want, you can select, go to statistics, select descriptive, then go to save option. You can take unstandardized or standardized residuals and unstandardized predicted values. Then click on OK. Can repeat. Go to analyze, regression, linear. Put all the variables like engine size, horsepower, wheelbase, width, length, curve weight, fuel capacity, fuel efficiency into the independent variable box. Then click on OK. Again, for first table, it is showing the descriptive for all the variables, whether it is taken as dependent variable or it is taken as independent variable. It is also showing the correlation between the variables. And the table you are getting is called as correlation matrix. Okay. And you will see that its diagonal elements are 1. Some variables are highly correlated, some variables are moderately correlated, whereas some are weakly correlated with Fourier resale value. If you see the column of Fourier resale value, price in 1000 is highly correlated, engine size is moderately correlated, horsepower is moderately correlated, wheelbase is slightly correlated, or you can say it is like uncorrelated, and its value is very much smaller than 0.1. Width is slightly correlated, length is uncorrelated, curve weight is moderately correlated, fuel capacity is moderately correlated, and fuel efficiency is also moderately correlated. All the variables are in the model. When you see here, what variables you are taken in the model, these are the variables considered into the model. All variables are considered into the model. बेटा एक काम किया करो, जब कोई क्वेश्चन पूछा करे तो उसको माइक दे दिया करो ताकि आवाज मुझ तक की आ जाए. ठीक है. I think in my there is no warning. Can you show me the warning? For the final model with dependent variable influence statistics is consistent. It's because the fit is perfect. Okay. Yeah, I think you have checked some other options also in the model. Or you have considered the predicted variable also in your model, which was saved earlier. Remove that one. ठीक है, आपने प्रेडिक्टेड वेरिएबल को भी मॉडल में कंसीडर कर लिया होगा, प्रेडिक्टेड वैल्यू को, उनको आप रिमूव कर दीजिए, प्रेडिक्टेड रेसिडुअल एंड प्रेडिक्टेड वैल्यूज, देन you will not get the model. Yes. Okay. You can take 0.25. There is no hard fast rule. You can take as a rule of thumb. You can take 0.25 as cutoff, or you can take 0.3 as slightly correlated. Above 0.3 and below 0.8 is taken as moderately, and above 8 it is taken as strongly. So we are getting negative values for wheelbase, but it is very, very small, 0.054. So you can say that it is uncorrelated with the price in 1000. And for fuel efficiency, it is 0.9339. That means fuel efficiency will increase, your resale value will decrease. Okay. Yes, we have to consider the magnitude. Sign tells if sign is positive for correlation, it tells one variable is increasing, the other will increase. Negative sign tells if one is increasing, other will decrease. Magnitude tells how strong the correlation is. Now we come to fourth table, which shows the model summary. If you compare the previous model, the value of R and R square, adjusted R square, all the three values are increased. So when you increase the number of variables in the model, these values also increases. And now you can say that the combined effect of all the variables like price in 1000, fuel efficiency, length, price in 1000, weight, fuel capacity, engine, their joint effect is highly correlated with the resale value. Its value is 0.973. R square is 0.974, which explains that 94.7% variation in the data can be explained with the help of this model, or 94.7% variation in Fourier resale value can be explained with the help of considered variable like Fourier resale value, fuel efficiency, fuel capacity, length, weight, and others. Now, what is the use of adjusted R square? Generally, it is considered that R square depends upon the number of observations as well as number of variables considered. So to remove the effect of number of variables considered and the number of observations, adjusted R square is calculated. Adjusted R square must also be high for a good fitted regression model. Again, model is fitted good, which is tell by ANOVA table as p value is smaller than 0.05. So you can say that our model fitted is good. Now we are using multiple regression models, so there will be a number of beta coefficients, but we consider that all the null hypothesis, all the betas are equal to 0 against at least one beta is not equal to 0. Okay. In language, we said that model is not fitted good as null hypothesis, against alternative as model is fitted good. But in symbols, we write H0 such that beta 1 is equals to beta 2 is equals to beta 3 up to beta n, that is you are considering n variable, then beta n equals to 0. And alternative that at least one beta should be different from 0. So which beta is different from 0, that can be obtained with the help of coefficient table. I am explaining just now. Again, you are getting the table of coefficient. Here variables are mentioned. Next is unstandardized coefficient. So unstandardized coefficient tells you change one unit of in the variable, then how much unit will change occur in the Fourier resale value. Suppose we are considering price in 1000. If you increase price in 1000 by 1 unit, then resale value will increase by 0.843 units. Now we consider next value, which is engine size. For its value is minus 1.148. That means if you increase the value of engine size by 1 unit, the Fourier resale value will decrease by 1.148 units. Now this T value is nothing but the beta divided by standard error. Okay, that is for price in 1000, 0.843 divided by 0.043, you will get the value of T. Constant is beta naught or mu. You fit the model if you consider model y is equals to mu plus alpha x plus beta x2. then constant is for mu. That will remain always present in the model. So if testing is not a concern, whether it may be 0 for the population or it should not be 0 for the population, but it will always remain present in the model. Now, this T statistics tells whether a particular beta is 0 or not. F test all beta is equals to 0 against at least one is not 0. Now, which one is not 0 is tested with the help of these T values and their significance. So for price, it is smaller than 0.05. You can set that price in 1000 is significant or has a significant impact over Fourier resale value. For engine size, it is 0.85. Then you can say that it has insignificant impact over the Fourier resale value, or you may remove this variable from the model as it is insignificant, or its p-value is larger than 0.05. Similarly, horsepower, it is 0.428, which is larger than 0.05. Only three variables, price in 1000, length, and curve weight comes out to be significant. For other variables, beta comes out to be 0. So you may not consider these variables for your model. That will not affect anything in the model. Now the one question, when we are going to fitting the model, how we decide which variable should be considered into model or not. एक तो हम अपने जजमेंट से कंसीडर कर सकते हैं कि हमें कौन सा वेरिएबल अपने मॉडल में कंसीडर करना है, कौन सा नहीं, लेकिन हमको लगता है कि वो वेरिएबल मॉडल में आना चाहिए, लेकिन हमारी स्टैटिस्टिक्स कह रही दैट इज इनसिग्निफिकेंट। तो हम क्या करेंगे? तो हमारे मॉडल के लिए कौन से वेरिएबल्स बेस्ट है, इसके लिए हम सिलेक्शन मेथड का यूज करते हैं। There are three methods. One is called as forward selection method, other is called as backward elimination method, third is called as stepwise method. In forward selection method, variables are entered one by one. That is, we start with the model y is equals to beta naught. Then we include one variable, suppose call as x1, model will become beta naught plus beta 1 x1, depending upon certain rules, not upon our choice. Which variable should be highly significantly correlated with the variable that comes into the model. Similarly, if we consider full model and remove the variables one by one, then that is called as backward elimination method. In stepwise method, we again start with y is equals to beta naught, enter variable one by one. But in stepwise method, a variable entered may be removed in the next step. मतलब कोई वेरिएबल आपका मॉडल में आ रहा है तो अगले स्टेप में वो रिमूव भी हो सकता है, डिपेंडिंग अपॉन देयर सिग्निफिकेंस. How we will do this into the SPSS? We will go to analyze. Regression, linear. It will remain, steps will remain same, only one change would occur. Here it is written as method at this place. It is showing enter. Okay. If you select enter, how many variables you will select in the model, that will be default represented in the analysis. आपको एनालिसिस के टेबल में वो सारे वेरिएबल्स मिलेंगे. Now change it to the forward. Okay, then click, then option. Okay, click on options. You will see one thing, use probability of f. So which variable is highly correlated with the model is judged with the help of this f value. For entering, we keep its significance as low as possible and for removing, we keep it much higher than entering. For entry, it is generally considered as 5% level of significance, and for removing it, it is considered as 10% level of significance. You can change. You can change entry at 0.1 and removal as 0.2. It depends upon you. But generally, it is considered 0.05 and 0.1. Then click on OK. Now, first two tables, one is descriptive and other is correlation, that will remain same as previous analysis. Now we come to another table, third table, which is variables entered or removed. So here you will see that in first step, price in 1000 is entered. In second step, length is entered. In third step, curve weight is entered. In fourth step, fuel capacity is entered. After fuel capacity, no variable remain highly affecting the model. So no other variable is included in the model. So your final model has only 4 variables: price in 1000, length, curve weight, and fuel capacity. And if you will see that R square for each step is increasing. For when you enter the price in 1000, R square comes out to be 0.912. When you include curve weight, I think, which is second variable. Sorry, second variable is length. You include length with price in 1000, R square will become 0.953. When you include price in 1000, length, and curve weight, it will become 0.938. And when you include fuel capacity also, it will become 0.944. And if you consider your previous model, which was using entered method, then R square was 0.945. So that means if you include more variables, then changes would occur in R square up to 4th or 5th place, which does not mean any sense. Now for each step, it is showing ANOVA table. Generally, since we are require final model, so we consider final ANOVA table, that is for model 4, which shows that model is fitted good. Similarly, for each step, you will get the value of the constants as well as the coefficients. And again, we consider the final model, that is 4th row of the model. First is for considering only price in 1000. Second is considering price in 1000 and length. So our final model consider 4 variables. So we consider only 4th value. Now you can see on each step which variable is excluded. Okay. Here beta coefficients, here significance, everything is mentioned. So you can say it, these are, I think, value of T is highest for length. Okay, after entering price in 1000, you will see that value of T is highest. Ignore the sign. Only consider the magnitude. No value is higher than 6.3. So for next model, you will consider, after price in 1000, you will consider length as entering variable. Then after length, then for second step, highest value is for curve weight. So for third step, curve weight will enter into the model. Similarly, for fourth step, fuel capacity is highest, 3.616. So for third step, fuel capacity will be entered. And when you see in last table, no variable is significant. Here you are seeing the significance value. All the variables are insignificant at 10% level of significance. Not 5, but 10% level of significance are all insignificant. So no variable will enter into the model further. Is it clear? Now you were using a save option continuously for unstandardized value and for residuals. What about that? When you go to the data, okay, then in last you will see there are a number of value PRE and RES. इस नाम से आपके डिफरेंट वेरिएबल सेव हो गए होंगे. आप चाहे वेरिएबल व्यू में लास्ट में जाके देख लें, चाहे आप डेटा व्यू में लास्ट में जाके देख लें. PRE1 is predicted values for model 1. RES_1 is residual values for model 1. That is, you have considered for univariate model. Similarly, you will get for model 2, that is for multivariate model, it is PRE2 and RES2 and so on. Now here you can see if you consider value PRE2 is 6.9918 and for it resale value is 16.36 and PRE2 is 16.99. So you can say that there is a difference of 0.06 unit. That means their model is predicting good. जितना ज्यादा आपका रेसिडुअल की वैल्यू कम होगी या प्रेडिक्टेड की वैल्यू ओरिजिनल डिपेंडेंट वेरिएबल के जितने पास होगी, आप कहेंगे आपका मॉडल उतना ही अच्छा जा रहा है या उतना ही अच्छा प्रेडिक्शन देगा. PRE is predicted value. Okay, you have used the save option, unstandardized predicted value, unstandardized residual value. So PRE is unstandardized predicted value and RES is unstandardized residual value. Okay, so you fit the model y is equals to beta naught plus beta 1 x. You put the different values of x, you will get the value of y. These value of y are in the predicted variable, and if you subtract it from original, you will get the residual values. These values can be used for testing the assumptions of the regression model. Okay, there are certain plots which can be made for testing the assumptions. Now I am coming to that. Now for regression model, we make certain assumptions. First assumption, your dependent variable or error term should be normally distributed. Second assumption, there should not be multi-collinearity. That means independent variables should be independent of each other. Third is, there should be homogeneity in dependent variable. That is, variance of the dependent variable should be constant. For if you remove one or two values and take variance and you consider the values considering all the variables, it may be stable. It must not be changed. Fourth, the value that does not depend upon the past value if you have time dependent data. For economics, if you are someone is from the background of economics, if you remember, you generally deal with the time data. That is, the budget of in the year 1991 was that, in 1992 budget was that, 1993 budget was that. So whether it should be dependent upon its past value or not, it is considered as autocorrelation. There should not be any autocorrelation in the data. How we check these assumptions? So there are two options. You can use residual plots for that. Generally, residual plots are used to test the hypothesis of homogeneity. That is, data must be homogeneous. For this, we take residual square and plotted it against the predicted values. So how you calculate residual square? So it is also helpful in considering my one option which was remaining in the previous session of data entry. How we compute the variables in the SPSS. For computing, we will go to data, go to option data. There will be, sorry, go to option transform. Not data, go to transform. There will be first option compute variable. Okay, go to data, then go to compute variable. Click on that. There is target variable. You can give any name as per your requirement to the target variable. It is the variable in which you want to save your values. I am considering it RESSQ, that is residual square. Okay. In numeric expression, you give the expression you want to square the residual, so you will write residual into residual. So it will give residual square. Okay, then click on OK. Then we go to our data and see that there is one variable RESSQ. Okay. Now go to file, sorry, go to graph, consider legacy dialog, then go to scatter plot. Select simple scatter, click on define. By default ये जो आपने वेरिएबल पहले कंसीडर किए थे ये उन्हीं को दिखाएगा. आप रीसेट वैल्यू पे, रीसेट वाली बटन पे क्लिक कर दीजिए. ओके, रीसेट पे क्लिक करेंगे तो आपका जो वेरिएबल्स वहां पे शो हो रहे थे वहां से गायब हो जाएंगे. पुट रेसिडुअल स्क्वायर ऑन y axis and click on reset value. Go to graph, scatter plot, select simple scatter. जब आप सिंपल स्कैटर पे क्लिक करेंगे एक विंडो ओपन होगी, उसमें रीसेट का बटन क्लिक कर दीजिए. देन रेसिडुअल स्क्वायर को y एक्सिस पे और अनस्टैंडर्डाइज्ड प्रेडिक्टेड वैल्यूज को, सॉरी, रेसिडुअल स्क्वायर को y एक्सिस पे और अनस्टैंडर्डाइज्ड प्रेडिक्टेड वेरिएबल को x एक्सिस पे ले लीजिए. क्लिक ऑन ओके. You will get such type of plot. Okay. So it is not showing any kind of pattern. If it shows some kind of pattern, whether it is increasing or it is parabolic or it is some other type, then you said your data is homogeneous. Sorry, if it is not showing any kind of pattern, you said your data is homogeneous. If it is showing some kind of pattern, you can say that your data is not homogeneous and your regression method is not suitable for the data. Further, you can also check the assumptions using regression option. Go to analyze and go to regression. Click on linear. There are options in statistics. Click on statistics button. Here option collinearity diagnostic. Okay. It will check the assumptions of multicollinearity, whether your variables independent variables are highly correlated or not. There is option Durbin-Watson. It will be helpful in checking the assumption of autocorrelation. Okay. Click on continue and click on OK. So when you consider the correlation table, see the column of price in thousand. Price in thousand is highly correlated with Fourier resale value. It is also highly correlated with horsepower. Okay. That means similarly, engine size is also highly correlated with horsepower. So you can say that the problem of multicollinearity occurs in your data set. And what effect when you click on these statistics? Okay, here you can see the collinearity diagnostic. It will show the collinearity diagnostic only for the variables which are in the final model. So here you can see that conditional index is not much higher, or eigenvalues are very small. So you can say that multicollinearity is not present in your final model. In original model, if you consider all the variables using enter method, then what happened? I think I should have changed the option. Now if you use enter method, you will get such table. You can see that first eigenvalue is 0.9. If an eigenvalue is high, that is more than 1 or more than 2, or the condition index which is higher than 100 for any variable, then you can say that the multicollinearity exists in your data set. Similarly, in first table, you will get one more thing. Here in model summary, when you see, you will see that there is a value of Durbin-Watson statistic. Rule of thumb says if value of Durbin-Watson is 0, that means positive autocorrelation is present. It is near to 2. There is no autocorrelation. And if it is larger than 2, then there is negative autocorrelation is present. So our value is near to 2, that is 1.5. So we can say that there may not be presence of autocorrelation in our data set. Okay. So it is all about the presentation related to the regression analysis. One more thing is remaining. What about the normality of the dependent variable? Now check you and tell whether the dependent variable is normal or not. It is normally distributed or not. इस कमेंट को नोट कर लो, ठीक है। इस कमेंट का आंसर बाद में देंगे। Now tell me about the normality of the data. How we check the normality of the variables? Which method is used? There are two options. You can use Kolmogorov-Smirnov test, which is in short is called as KS test, or there is another option in analyze. Go to descriptive. There is option explore. Okay. Select Fourier resale value as dependent. In plots, select normal plot with tests and check other. Okay, repeating. Go to analyze. Descriptive statistics. There will be explore. Click on that. Put Fourier resale value as dependent variable. Okay. Go to plots. Click on normal plots with test. Okay. Uncheck stem and leaf as it is not required at present. Click none in the box plot as box plot is also not required. Click on continue. Then below the variables, you will see display both statistics and plot. We need only to test the normality. So we use plots only. Then click on OK. So using explore option, you will get 3 different tests for normality. One is Kolmogorov-Smirnov test. You said KS test. Other is Shapiro-Wilks test, which is also used for normality. And third one, which was explained by the Rohini ma'am, I think it was QQ and PP plot. So for Kolmogorov-Smirnov and Shapiro-Wilks, you can see that the p value is smaller than 0.05. So the null hypothesis that the dependent variable follows normal distribution is rejected also. So your data is non-normal. So in that situation, you cannot use the regression analysis. So what we do? तो पहली चीज तो ये कहूंगा, मैंने जानबूझ के नॉर्मेलिटी बाद में बताया है। अगर आपको एनालिसिस परफॉर्म करनी हो तो सबसे पहला काम आप नॉर्मेलिटी की टेस्टिंग करेंगे, ठीक है। योर डिपेंडेंट वेरिएबल शुड बी नॉर्मल। इंडिपेंडेंट नॉर्मल है कि नहीं हमें कोई मतलब नहीं, बट डिपेंडेंट शुड बी नॉर्मल। तो रिग्रेशन एनालिसिस परफॉर्म करते समय आपने स्कैटर प्लॉट बना लिया। स्कैटर प्लॉट बनाने के बाद आप नॉर्मेलिटी को चेक करेंगे। अगर डेटा आपका नॉर्मल नहीं है तो आपका पियर्सन कोरिलेशन भी बेकार है और आपका रिग्रेशन एनालिसिस भी वेस्ट ऑफ टाइम है। ठीक है, नाउ व्हाट वी डू फॉर कोरिलेशन, वी कैन यूज अनदर ऑप्शन विच इज कॉल्ड एज पियर्सन्स कोरिलेशन, सॉरी स्पीयरमैन कोरिलेशन. For obtaining Spearman correlation, we go to again analyze, correlate, bivariate. Okay, जैसे अभी हमने कोरिलेशन परफॉर्म किया था. Take the variables into the variable box whichever you want, not necessary all, not necessary one. कम से कम 2 वेरिएबल होने चाहिए, ज्यादा से ज्यादा आपकी मर्जी, आप जितने वेरिएबल्स उसमें चाहें आप उसमें कंसीडर कर सकते हैं. क्लिक द ऑप्शन ऑफ द स्पीयरमैन एंड अनचेक पियर्सन. ओके, click on Spearman and uncheck Pearson, then click on OK. Repeat कर रहा हूँ again. Go to analyze, correlate, bivariate. Okay. Put the variables you want for which correlation is to be computed in the variables box. वेरिएबल बॉक्स में आपको जिन वेरिएबल्स के बीच में कोरिलेशन देखना है उनको वेरिएबल में पुट कर देंगे. स्पीयरमैन को चेक कर देंगे, पियर्सन को अनचेक कर देंगे. ओके, देन क्लिक ऑन ओके. Now you see that for Fourier resale value, again price in 1000 is highly positively correlated. Engine size is moderately correlated. Horsepower is moderately correlated. Width, length are slightly correlated. Curve weight is moderately correlated. Okay. So Spearman is interpreted in same manner as Pearson's correlation coefficient. But for normal data we use Pearson. For non-normal data we use Spearman. दूसरा, अब हम रिग्रेशन में क्या करें, तो रिग्रेशन के लिए हम कोशिश करते हैं कि हमारा वेरिएबल किसी तरह से नॉर्मल हो जाए. उसके लिए हम सर्टेन ट्रांसफॉर्मेशंस यूज करते हैं. We can convert our dependent variable into z scores using variable minus mean upon its standard deviation, or we can use log transformation. How we use log transformation? For that we go to data, we go to transform, go to compute variable. Give name to the target variable. Ma'am, I will take at least 15 to 20 minutes more. Okay, so there is target variable I am giving. अगर आपके में बाय डिफॉल्ट आपने पहले एक कंप्यूटेशन किया था, रेसिडुअल स्क्वायर कैलकुलेट किया था, अगर वो आ रहा है आप रीसेट वाली बटन पे क्लिक कर दीजिए. ठीक है, टारगेट वेरिएबल में आपको लॉग वैल्यूज को जिस नाम से सेव करना है आप वो वेरिएबल का नाम डिफाइन कर दीजिए. देन क्लिक ऑन अरिथमेटिक इन फंक्शन ग्रुप. हियर at this place there are certain functions in which there is option arithmetic. Click on that. Log resale. So when you click on arithmetic, जैसे ही आप arithmetic पे क्लिक करेंगे आपको नीचे कुछ ऑप्शंस दिखाई देंगे. ठीक है, कुछ फंक्शंस पहले नहीं शो हो रहे होंगे, जब आप arithmetic पे शो क्लिक करेंगे तो आपको नीचे फंक्शन शो होने लगेंगे. उसमें से आप लॉग को सेलेक्ट कर लीजिए. ओके, You can, if you want, you can select log 10. If you want, you can select natural log. That is exponential log. You can also say that. Then click on arrow button. At this place, there is arrow button. You can click on it. Now it will show in expression ln, then bracket, and within bracket, there will be a question mark. Then select the variable Fourier resale value and click on arrow button at this place. तो क्वेश्चन मार्क की जगह पे रीसेल आ जाएगा. देन क्लिक ऑन ओके. तो इससे आप देखेंगे कि आपका एक वेरिएबल लॉग रीसेल जनरेट हो गया. ओके. अब अगर आप चाहें तो आप इसकी नॉर्मलिटी चेक कर सकते हैं. अगर ये नॉर्मल है तो आप इसको एज ए डिपेंडेंट वेरिएबल लेकर के मॉडल फिट कर सकते हैं. Is it clear? Now only there are two options are remaining of data entering also. So I am switching to that. दो ऑप्शन रह गए हैं, अब मैं उनका यूज करने जा रहा हूँ. One is record, other is split file. Okay. तो आपके साथ एक और डेटा शेयर किया गया होगा विच इज demo.sav. उसको ओपन कर लीजिए. ठीक है. इसमें सर्टेन वेरिएबल्स थे, उस दिन मैंने डेटा एंट्री भी कराई थी. अब मैं इसमें एक वेरिएबल है मैरिटल स्टेटस का, जिसमें ये बता रहे हैं पर्सन मैरिड है या अनमैरिड है. एक वेरिएबल है इनकम का. ठीक है. आपसे कहा जाए पर्सन की एवरेज इनकम बताइए. आप जाएंगे एनालाइज पे, डिस्क्रिप्टिव पे, उसमें डिस्क्रिप्टिव का ऑप्शन यूज करेंगे या फ्रीक्वेंसी का ऑप्शन यूज करेंगे. वेरिएबल को वेरिएबल बॉक्स में पुट करेंगे, मीन को कैलकुलेट कर लेंगे. मैं कहता हूं आप ये चेक करिए कि क्या मैरिड पर्सन और अनमैरिड पर्सन की इनकम सेम है. नॉट टू टेस्ट, केवल चेक करिए क्या उनकी एवरेज वैल्यू सेम है या डिफरेंट है. आप कैसे करेंगे? यस. तो एक तो तरीका है, आप दो अलग अलग फाइल बना लीजिए, वन फॉर मैरिड, अदर फॉर अनमैरिड. और देयर इज ऑप्शन ऑफ स्प्लिट फाइल. गो टू डेटा, there is option split file. Okay, click on that. You will get three options. Analyze all the cases, यानी कि सारे केस एनालाइज करने. कंपेयर ग्रुप्स एंड ऑर्गेनाइज आउटपुट बाय ग्रुप्स. अगर आप कंपेयर ग्रुप्स करेंगे तो आपको एक ही टेबल में ग्रुप्स की वैल्यू मिल जाएंगी. अगर आप ऑर्गेनाइज आउटपुट बाय ग्रुप्स करेंगे तो आपको दोनों ग्रुप्स के लिए अलग अलग टेबल बन के मिलेंगे. So first I am using compare groups. Put marital status into grouped based on. Okay. Go to data, select split file option. Data पे जाएंगे, split file पे जाएंगे. उसमें ऑप्शन कंपेयर ग्रुप्स को सेलेक्ट करेंगे. देन मैरिटल स्टेटस को ग्रुप्ड बेस्ड ऑन में पुट कर देंगे. देन क्लिक ऑन ओके. जब आप ओके करेंगे तो आपके आउटपुट में एक ये मैसेज शो हो जाएगा, स्प्लिट फाइल लेयर्ड बाय मैरिटल, या जो भी वेरिएबल आपने स्प्लिट करने के लिए लिया है. ठीक है. देन गो टू एनालाइज, go to descriptive, select descriptive, click on that. जैसे आप मीन कैलकुलेट करते हैं, select household income as variable, then click on OK. ठीक है. Now you will see that for unmarried person, average income is 69.2723 and for married person is 69.6804. यानी कि मैरिटल स्टेटस कहीं पर भी इनकम को इफेक्ट नहीं करता है. ओके, इज इट क्लियर द यूज ऑफ स्प्लिट फाइल? देयर इज वन मोर ऑप्शन, सेलेक्ट केस. जैसे हम कहें कि आपके पास डेटा सेट में एक वेरिएबल है एजुकेशन का, जिसमें डिड नॉट कंप्लीट हाई स्कूल, सम कॉलेज, कॉलेज डिग्री एंड पोस्ट ग्रेजुएट के ऑप्शन है. हमें केवल मीन चाहिए जिन्होंने हाई स्कूल कंप्लीट नहीं किया है, उनके लिए एवरेज इनकम क्या है. हाउ वुड यू कंप्यूट? केवल एक ग्रुप के लिए, हमको बाकी से मतलब नहीं है. तो अगेन यू कैन यूज स्प्लिट फाइल, but it will give for all the groups. तो किसी एक पर्टिकुलर ग्रुप के लिए हमें ऑब्टेन करना है, we go to data, there is option select case. Okay, go to data, there is option select case, click on that. There is certain conditions, all cases मतलब सभी केस को एनालाइज करना है. इफ कंडीशन इज सेटिस्फाई मतलब कोई कंडीशन आप देंगे, वो अगर सेटिस्फाई हो रही है तब आप कंसीडर करेंगे. आपको डेटा के रैंडम सैंपल जनरेट करके उसके लिए ऑब्टेन करना है. देन यू यूज रैंडम सैंपल ऑफ द केसेस. किसी रेंज के लिए करना है तो यू कैन से बेस्ड ऑन टाइम और केस रेंज. सो आई एम सेलेक्टिंग इफ कंडीशन इज सेटिस्फाइड. क्लिक ऑन if condition is satisfied, then click on if button. ओके, जब आप if वाली बटन पे क्लिक करेंगे आपको एक ये बॉक्स, डायलॉग बॉक्स खुल के मिलेगा. इसमें वेरिएबल आपका होगा ईडी, और अगर आप वेरिएबल लेवल से देख रहे हैं तो लेवल ऑफ एजुकेशन, इसको इधर बॉक्स में पुट कर देंगे इक्वल टू 1. जिन्होंने हाई स्कूल कंप्लीट नहीं किया था उनके लिए कोड था 1, सो आई हैव रिटन ईडी इज इक्वल्स टू 1. क्लिक ऑन कंटिन्यू, क्लिक ऑन ओके. ठीक है, so it is this type of message will be generated. आप अपने डेटा पे जाएंगे, डेटा को देखेंगे तो डेटा व्यू में कुछ वैल्यूज पे क्रॉस बन के आ रहा होगा स्टार्टिंग में. ठीक है, जिन वैल्यूज पे क्रॉस बन के आ रहा है ये आपके डेटा में सेलेक्ट नहीं हुई है, एनालिसिस में कभी भी कंसीडर अब नहीं होंगी जब तक आप ऑप्शन चेंज नहीं करते हैं. ठीक है, और जो वेरिएबल वैल्यू क्रॉस नहीं है that will be considered for the analysis. So you can see that go to analyze descriptive statistics, there is option of descriptive. By default it is considering household income. Click on OK. So you can see that household income is 59.86. जब अभी आपने मैरिड अनमैरिड के लिए किया था इसकी वैल्यू 69 थी, यानी कि सभी केस को एनालाइज कर रहे हैं तो इट कम्स आउट टू बी समथिंग अराउंड 69. लेकिन जब आप केवल एक नॉट कंप्लीटेड हाई स्कूल को कंसीडर कर रहे हैं तो उनकी एवरेज इनकम 59.86 है. दैट इज द एप्लीकेशन ऑफ स्प्लिट फाइल. Okay, now again we go to data and analyze all the case. Only one topic is remaining. Go to select case, select option all cases, click on OK. अभी आपके डेटा में एजुकेशन की 4 या 5 कैटेगरीज हैं, 1 2 3 4 5 अप टू हाई, नॉट अप कंप्लीटेड हाई स्कूल, अप टू हाई स्कूल, इंटरमीडिएट, ग्रेजुएट, अदर। मैं कह रहा हूं इनको 2 में डिवाइड कर दीजिए, हमारे पास केवल इलिटरेट और लिटरेट बचे। इलिटरेट में वो आएंगे हु हैव नॉट कंप्लीटेड द हाई स्कूल, लिटरेट में बाकी। आप कैसे करेंगे? For that purpose we use the option recode. Okay, option recode. Go to file, sorry, not go to, go to transform. In transform there will be option recode in same variable, recode in different variable. रिकॉर्ड इन सेम वेरिएबल अगर आप करेंगे तो आप डेटा में जो भी मॉडिफिकेशन कर रहे हैं, 4 कैटेगरीज की आप 2 कैटेगरीज बना रही हैं, वो आपकी उसी वेरिएबल में सेव हो जाएंगी, आपका ओरिजिनल डेटा लॉस हो जाएगा। ठीक है, वहीं आप रिकॉर्ड इन डिफरेंट वेरिएबल करेंगे तो एक नया वेरिएबल जनरेट हो जाएगा, आपका ओरिजिनल वेरिएबल भी रहेगा, आपका नया वेरिएबल भी रहेगा, तो हमारा डेटा कहीं भी किसी भी स्टेज में लॉस ना हो। सो वी यूज रिकॉर्ड इन डिफरेंट वेरिएबल। क्लिक ऑन दैट। अब आपको कौन से वेरिएबल को रिकोड करना है? तो आई थिंक इट वाज एजुकेशन, लेवल ऑफ एजुकेशन। ओके, जब आप एजुकेशन को राइट में बॉक्स में ट्रांसफर करेंगे तो आपके ये नेम और लेवल वाले वेरिएबल्स हाईलाइट हो जाएंगे। नेम में आप वेरिएबल का नाम दे दीजिए, सपोज आई एम राइटिंग ED1। लेवल में आप लिख दीजिए एजुकेशन रिकोडेड। ओके, हाँ, लेवल में आप स्पेस दे सकते हैं, नेम में स्पेस नहीं देंगे, लेवल में आप स्पेस दे सकते हैं, ये वेरिएबल लेवल को डिफाइन करता है डेटा व्यू में। देन क्लिक ऑन चेंज। जैसे ही आप चेंज करेंगे, ईडी के बाद एरो था, एरो के बाद क्वेश्चन मार्क था, वो क्वेश्चन मार्क की जगह पे ED1 आ जाएगा। ठीक है, क्लिक ऑन ओल्ड एंड न्यू वैल्यूज। Click on old and new values at this place. There are certain options. वैल्यू, अगर हमें किसी पर्टिकुलर वैल्यू को रिकोड करना है, वी यूज ऑप्शन वैल्यू। अगर हमें किसी एक रेंज को, जैसे सपोज इनकम है 75 to 85, उसका हमें एक ग्रुप बनाना है, वी विल यूज रेंज ऑप्शन। अगर मिनिमम से हमें किसी एक पर्टिकुलर वैल्यू 0 से 60 तक का एक ग्रुप बनाना है, वी यूज रेंज लोवेस्ट थ्रू वैल्यू। ठीक है, किसी वैल्यू से मैक्सिमम वैल्यू का एक ग्रुप बनाना है, वी यूज रेंज वैल्यू थ्रू हाईएस्ट। ठीक है, अभी इसका भी एग्जांपल बताता हूं। वैल्यू 1 इज टेकन एज अगेन वैल्यू 1, क्लिक ऑन ऐड। वैल्यू में 1, ओल्ड वैल्यू में 1, न्यू वैल्यू में 1, देन क्लिक ऑन ऐड। फिर से रिपीट कर दे रहा हूं, वैल्यू लिखी है, ओल्ड वैल्यू में वैल्यू ऑप्शन, क्लिक ऑन राइट इन द बॉक्स 1, then on right hand side there is new value, click on that and click on write 1, click on add all other values, select all other values in old value में all other values लेंगे और वैल्यू में उस पे 2 लिख देंगे, click on add, then click on continue and click on OK। ठीक है, तो अभी तक की एजुकेशन में जो आपके 4 ग्रुप आ रहे थे, अब आप ED1 की फ्रीक्वेंसी टेबल बना के देख लीजिए, उसमें आपके सिर्फ 2 वैल्यूज आ रही होंगी, 1 एंड 2। Here you can see that only 1 and 2 are present. तो इस टाइप से हम रिकोडिंग कर सकते हैं। नॉट हम केवल कैटेगोरिकल को, हम कॉन्टिन्यूअस डेटा को भी इसकी मदद से कैटेगरी में कन्वर्ट कर सकते हैं। कैसे करेंगे? जैसे हमको इनकम की कैटेगरी बनानी है, वी गो टू अगेन ट्रांसफॉर्म, recode into different variable, click on reset, take household income as dependent variable, sorry numerical variable, आउटपुट वेरिएबल में नाम दे दीजिए सपोज इनकम अंडरस्कोर कैट, देन क्लिक ऑन चेंज, देन क्लिक ऑन ओल्ड एंड न्यू वैल्यू। सपोज हमको चाहिए 0 से 50 वाली वैल्यूज का एक ग्रुप जाए, तो हम सेलेक्ट करेंगे रेंज लोवेस्ट थ्रू 50, वैल्यू हम दे देंगे 1, देन क्लिक ऑन ऐड। अब हम चाहते हैं 50 से 100 का दूसरा ग्रुप बन जाए, तो 50.0012 कहां से? जैसे हमने अभी रिकॉर्ड इन डिफरेंट वेरिएबल का यूज किया था, ठीक है, इनकम को लिया, इधर हमने एक नए वेरिएबल का नाम दे दिया, ठीक है, क्लिक ऑन चेंज। आप अपने मन से कोई भी नाम दे सकते हैं, नॉट नेसेसरी कि जो मैं नाम यूज कर रहा हूं वही आप भी यूज करिए। देन क्लिक ऑन चेंज, देन ओल्ड एंड न्यू वैल्यूज, ठीक है, ओल्ड एंड न्यू वैल्यूज में रेंज लोवेस्ट थ्रू वैल्यू 50 कंसीडर्ड एज 1, ठीक है, लोवेस्ट थ्रू वैल्यू में 50 लिखिए, न्यू वैल्यू में 1, क्लिक ऑन ऐड। ओके, हम चाहते हैं 50 से बड़ी लेकिन 100 से छोटी वैल्यूज का दूसरा ग्रुप बन जाए, वी राइट 50.001 to 100, न्यू वैल्यू में 2, क्लिक ऑन ऐड। और 100 से बड़ी वैल्यूज का तीसरा ग्रुप बन जाए 100.001, कंसीडर न्यू वैल्यू 3, click on add, then click on continue and click on OK. ठीक है, अब आप इनकम की फ्रीक्वेंसी निकाल लीजिए, आप चाहें तो इनकम कैट का एक नया वेरिएबल बन गया है। गो टू डिस्क्रिप्टिव फ्रीक्वेंसी, put income category here, then click on OK. Here you can see income category में आपकी केवल 3 कैटेगरीज। ओके, इज इट क्लियर? Now it is all over about today's hands-on practice. आप लोगों को कुछ पूछना है? ये आपका जो डेटा सेट आप यूज कर रहे थे उसके लास्ट में चले जाइए, आपके जितने भी वेरिएबल जनरेट होंगे उसके लास्ट में आए। ओके, एनी अदर क्वेश्चन? I think it is better to report both. Any other question? तुम्हें विकास ऑनलाइन में देखो कौन कौन से क्वेश्चंस हैं। एक क्वेश्चन मैंने नोट करने को कहा था, ऑनलाइन में एक क्वेश्चन आया है, इन केस द डिपेंडेंट एंड इंडिपेंडेंट वेरिएबल्स आर नॉट कोरिलेटेड बट सिग्निफिकेंट रिजल्ट्स आर ऑब्टेन्ड यूजिंग regression. I think that is not possible. If your variables are not correlated, then regression will never give significant result. If it is giving significant result, then I think you are performing some error in the analysis.